Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on the nephron. Learning objectives of this presentation lecture. In this lecture, we are going to discuss about the parts of nephron, the components of nephron, what the nephron is made up of, and where these components or the parts of nephron are located inside the kidney. Okay, so starting with the first point. Okay, so this is the title of today's discussion, parts of a nephron. See, uh, nephrons are the functional units of kidneys. Nephrons are considered as the functional units of the kidney. The reason why they are considered as the functional unit is that they are producing the urine. Okay, so they are the urine forming units inside the kidney. That's why they are known as the functional unit. And here inside the kidney, one one nephron is shown. For example, this is the nephron, and they have zoomed that nephron, so the entire nephron look like this. Okay, now each nephron consists two part. Nephron is made up of two part. One part is known as a renal corpuscle, and a renal corpuscle is the part where blood plasma is filtered, and second part is the renal tubule, in which the filter passes. So this filtrate which comes out from the capillary blood is known as glomerular filtrate or the filtered fluid. For example, over here, see, this is the on screen you are looking at the entire nephron, and the initial part, this portion, this is the cup like portion, this is known as Bowman's capsule, or also known as glomerular capsule. Now we know that afferent arteriole enters and efferent arteriole leaves Bowman's capsule. So one more figure I would like to show you for this. For example, over here, see, this is the entire renal corpuscle they are showing. Have a look at this. Okay, and as you can see here, this is the afferent arteriole. Okay, and this is the efferent arteriole. Afferent arteriole, as we can see, it is entering into the Bowman's capsule, and efferent arteriole is leaving the Bowman capsule. Now from afferent arteriole inside Bowman capsule there arise numerous blood capillary, and the network of this blood capillary is known as glomerulus. So this glomerulus fits inside the Bowman capsule. Bowman's capsule, another name for Bowman capsule is the glomerular capsule. So together this glomerular capsule and glomerulus, they are known as renal corpuscle. Now you see, this is the afferent arteriole, and it is having a greater diameter when we compare it with the afferent arteriole. And we know the capillary, they are very tiny one, and their walls are very thin. Okay, so now you can understand that here the larger diameter, and in capillary very small diameter, and here also the lesser diameter or the smaller diameter is present. So afferent arteriole, they are also having the smaller diameter. So now due to this difference in the diameter, what happens, the blood that flows in all this glomerular capillary, okay, the blood flows with a pressure. And since the wall of the capillary, they are the thinner one, what happen, the blood which is present in the capillary, plasma components of blood ooze out. Okay, so from blood plasma, water comes out, waste material comes out, nutrients comes out, and some ions comes out. So all this component, water, waste material, nutrient, and ions together, all these components are known as the filtrate fluid. Okay, and here this tube that you are looking at, okay, this is the renal, actually this one is the renal tubule. So now the filtrate is entering into the renal tubule. Okay, so once again, the first point that we have discussed, okay, this was the first point. So parts of nephrons are having two parts. Okay, one part is known as renal corpuscle. Renal corpuscle is made up of Bowman capsule plus glomerulus, and second part is the renal tubule in which the filtrate fluid passes. Okay, now second point. Now, in our previous lecture, we had discussed about the blood supply of the nephron. Okay, now the two component of renal corpuscle are glomerulus, that is the capillary network that we have seen in the figure, okay, and the glomerular capsule or the Bowman capsule. And glomerular capsule or Bowman capsule is a double wall epithelial cup, and this double wall epithelial cup or Bowman capsule or the glomerular capsule surrounds the capillary network of glomerulus, and this is how the renal corpuscle is formed. Okay, so on screen now you are looking at the renal corpuscle and renal corpuscle component. So one is glomerular capsule, and inside glomerulus is present. So together glomerular capsule and glomerulus, they are known as renal corpuscle. And this tube like structure, this entire, okay, this tube like structure is the renal tubule. This one is the renal tubule. Okay, so this one is the, this is the, this is the second point of our discussion. Okay, now we are moving on the third point. Okay, see, once the filtrate ooze out from the blood plasma, okay, and this filtrate is coming out from the blood, where it is coming out, in the glomerular capsule, and then this filtrate enters into the renal tubule. Okay, so for example here you can see in this figure, okay, here they are showing afferent arteriole. From the afferent arteriole, capillary network is formed. This is the capillary network. Okay, all these capillary join together, they form the efferent arteriole, and blood is flowing with the pressure inside the capillary. So that's why some of the components of plasma comes out, and that is known as filtrate. So this filtrate fluid now enters into this tubule, and this tubule is the renal tubule. So this portion is the renal corpuscle, and this tubule is the renal tubule. Okay, so now renal renal tubule consists of three component, or renal tubule is divided into three part. First part is known as the proximal convoluted tubule, in short PCT. Second part is the nephron loop, also known as loop of Henle, and the third part is known as distal convoluted tubule, in short DCT. So here first of all you see the arrangement where exactly the nephrons are present. So this is the renal cortex they are showing, then this is the renal medulla, the pyramid part, and you see this yellow color is the entire nephron they are showing. Okay, and now we are enlarging that nephron. So on screen now, this is the entire, this one is the entire nephron. Okay, and see, this one, the portion of the tubule which is present close to the renal corpuscle, for example this part. Okay, this portion which is very close to renal corpuscle, this portion is known as proximal convoluted tubule, in short PCT. Okay, then this portion, this U-shaped portion, this entire portion is known as loop of Henle. Okay, or the nephron loop. So this one is the loop of Henle or nephron loop, and the distal part. Okay, this distal portion, this portion is known as distal convoluted tubule, in short DCT. So in the third point we have learned that renal tubule is having three parts. It is divided into three parts: PCT, loop of Henle, and DCT. Now the fourth point. Now why the initial portion of renal tubule is known as proximal? Because it is very close to renal corpuscle, and in fact it attached to glomerular capsule. That's why. So here you can see that this proximal convoluted tube, this part is joining, this portion is joining the glomerular capsule. Okay, and since this portion is very close to glomerular capsule, so that's why proximal. Okay, that's why it is known as proximal. Proximal means in the vicinity or in the closeness. So proximal denotes part of the tubule which is attached to glomerular capsule, and distal meaning the part of the renal tubule which is present further away. So this portion of renal tubule is present further away from the glomerular capsule, and this part is known as DCT. And what is the meaning of convoluted? Convoluted meaning the tubule is tightly coiled rather than the straight. So here you can see, okay, in PCT and DCT the tubule is the coiled one, and here also the tubule is the coiled one. Okay, so this is the This one is the fourth point. Okay. I'm showing you the entire figure. Now we are discussing the fifth point. Now, the renal corpuscle and both convoluted tubule lie within the renal cortex. I'm showing you this. See, here in the cortex, this is the cortex portion, and this is the medullary portion of the kidney. Okay, and here two type of nephrons are shown. One type of nephron known as cortical nephron, and second type of nephron is known as juxtamedullary nephron. Now here in this figure, for example, let's say this is juxtamedullary nephron. Okay, this one. So here you see this one is the renal corpuscle. So where the renal corpuscle is present, so inside the cortex, right? And PCT is present in the cortex, DCT is present in the cortex. Okay, and in case of cortical nephron, where renal corpuscle is present in the cortex, where PCT is present, so this is the PCT is present in cortex. Where DCT is present, DCT is present in the cortical region. Okay, so this is the fifth point, that the renal corpuscle and both the convoluted tubule PCT DCT, they are present in the renal cortex. Now Henle's loop. So loop of Henle or the nephron loop extends into the renal medulla and makes a hairpin like turn and then returns to the renal cortex. For example, over here you see, okay, this portion, this PCT, okay, this PCT then straighten up, and this straight portion of renal tubule then enters into medulla. Okay, the straight portion enters into medulla, and now again this renal tubule is making hairpin like turn. So this is the hairpin like turn. Okay, now this part is, this tubule is moving up. Okay, so this portion, the ascending part, okay, and this portion, this is the hairpin like structure, the U-shaped portion that you are looking at. Okay, so so we can say the nephron loop or loop of Henle, where it is present, so it is present in the medulla. It is extended, it is elongated in the medulla. Okay, and this nephron loop, the ascending part, once again it enters into cortex, and now once again this renal tubule becomes the convoluted one, coiled one, and this coiled portion is known as DCT. Okay, so this is the fifth point, and this is the figure. Okay, now we are discussing the sixth point. Okay, now the DCT, distal convoluted tubule of many nephron, they empty into single collecting duct. For example, over here, see over here, this is the collecting duct. Okay, and as you can see, this DCT opening into collecting duct, and here this part, this is also DCT of cortical nephron, this DCT opening into collecting duct. And see, now what is this portion meaning? So here, so we can understand there are many nephron, in fact the million nephrons are present in the kidney. So there are so many, even though in the figure they are showing only two, but we can understand there are so many nephron. So here let's say this is the DCT of another nephron, so this DCT is opening, so here one DCT is opening, okay. So then here one DCT of another nephron is opening, here also the DCT of another nephron. So many DCTs are opening into a single collecting duct. Okay. Now where these collecting ducts are going? So collecting duct, they merge together, they join together, they unite, and they open into papillary duct. Okay, and papillary duct number, several hundred papillary ducts are present in the kidney, and this papillary duct, they drain the urine into minor calyx. So in the figure I am showing you, for example in this figure, okay, over here you see distal convoluted tubule. This distal convoluted tubule is opening into, this one is the collecting duct. So see, here one DCT is opening, here DCT of another nephron, then here also DCT, here also DCT of another nephron. So all these DCTs are opening into the single collecting duct. And collecting ducts, see here they are showing one, so here there is another one, okay, here we can draw, then another one, okay. So collecting ducts, they merge together and they open into papillary duct, and from papillary duct the urine enters into minor calyx. Okay. Now you might be imagine that earlier it was filtrate, and now we are telling it like a urine. Okay. The reason is urine formation take place. Okay. So filtrate, when the filtrate is moving, see, in urine formation there are three stages. Okay. First is the glomerular filtration stage, then the second one is the reabsorption and the secretion. These are the three stages. So in that three stages, the filtrate is converted into urine. So that's why ultimately or the finally the urine is shown. Okay. So filtrate, we can say filtrate is now converted into urine when filtrate passes to the renal tubule and finally reaches to this minor calyx. It is converted into urine now. Okay. So this figure, read all the names. Okay. And this nephron is the cortical nephron. Okay. And here you see flow of fluid through a cortical nephron. Okay. So okay, so we were discussing the sixth point. Okay. So papillary duct, they drain urine into minor calyx. Okay. Now we are discussing the seventh point, but before that, See here also. Okay. Here also. See in this figure, this one is collecting duct, this one is collecting duct, and this one is collecting duct. All this collecting duct, they are opening into papillary duct, and papillary duct, they drain urine into minor calyx. Okay. Now we are discussing the seventh point. Now, in the seventh point, the collecting duct and papillary duct, they extend from the renal cortex through the renal medulla to the renal pelvis. In the figure, you see this. For example, over here, one nephron is shown. Okay, collecting duct of this nephron, collecting duct for this nephron. Okay, because it is not only for the, it is not that the only one nephron is opening into this collecting duct. We are now knowing that many nephron, they open, the DCT portion of the nephron opens into collecting duct. Now collecting duct together, they open, many collecting duct, they open into several hundred papillary duct, and this papillary duct, so now papillary duct in which the urine is present. So now papillary duct drain urine into minor calyx, and from minor calyx the urine pass to the major calyx, then the urine pass to renal pelvis. From renal pelvis urine enters into ureter. Now this ureter opens into urinary bladder. Urine is urinary bladder for a time being, drop by drop is filled with the urine, and finally when it is fully filled with the urine, then we feel the urge to urinate, and from the urinary bladder through urethra the urine passes, and we urinate outside our body. Okay, so this is the entire path, okay, of the filtrate and urine, where both the fluids are passing in the kidney. Okay, now in the kidney we know there are 1 million nephrons are present. Okay, but the number of collecting duct is smaller one, so less number of collecting ducts are present in comparison with the nephron, and the papillary duct, they are still present the fewer number. So nephrons are, we can say nephrons are present in the highest number, then in small number collecting duct, and in few number, several hundred papillary ducts are present in the kidney. Okay, so this is the seventh point of our discussion, and now we are moving on the eighth point. Now before that I would like to show you this figure, so have a look at this figure. Okay, okay, now the eighth point. See, now in a nephron, the nephron loop connect to the proximal and distal convoluted tubule. Once again, nephron. So in other word, we can say nephron loop the portion of nephron loop where it is present. So between PCT and DCT, nephron loop is present. Simply, we can say like that. For example, over here, this is PCT, this one is DCT, and in between PCT and DCT, we can see that this one is the nephron loop or the loop of Henle. Now, the first part of the nephron loop begins at the point where the proximal convoluted tubule takes its final turn downward. For example, here this one is the PCT they are showing, and this is the final turn downward of PCT. So as this is the final turn downward of PCT, so from here, from this point right now, that this point, okay, now onwards, so now onwards, this is the nephron loop, okay, and this entire nephron loop extend up to where the DCT begins. So let's say at this point the DCT begin, okay, so between this portion and this portion, the entire this U-shaped tube is known as the loop of Henle or nephron loop. So this is the 8th point, okay, nephron loop. I'm showing you this figure. This one. And here you see cortex and medulla is written. So let me draw a line. So here, okay, so we can understand that all these structures, renal corpuscle, PCT, DCT, where they are present, so they are present in cortex, and the loop of Henle is present in medulla. Okay. Now the 9th point we are discussing. Now as we have seen that the renal loop, it begins in the renal cortex. When it begins, so it joins with PCT, and then it extends downward into renal medulla in U shape that we have seen, and in the medulla it is known as the descending limb of the nephron loop, and then it will make the hairpin like turn, then return to the renal cortex, and finally this nephron loop is going to terminate when it joined with the distal convoluted tubule, okay, and this part is known as the ascending limb of the nephron loop. So now you read this point, and with the figure I am explaining what they are trying to explain us, that see this portion at this part, okay, now this part, the renal nephron loop start, okay, this is the beginning, and this portion here, the nephron loop ends. Now you see this portion, okay, so this portion with this is the descending limb of nephron loop. You see the diameter, okay, so so larger diameter this part is having, so that's why this portion is known as thick segment. Now there is a decrease in diameter, okay, so that's why this segment is known as thin segment. Now this thin segment is making hairpin like turn, so this is the hairpin like turn. Okay, now after hairpin like turn, this renal tubule is ascending this portion, okay, ascending. So this part having the greater diameter, and this portion is known as the ascending limb, and this ascending limb finally opens into DCT. Okay, so this was the ninth point. Okay, now we are discussing the 10th point. Okay, see here in the kidney, as we can see in the figure, there are two type of nephron. One type of nephron, they are known as cortical nephron. 80 to 85% nephron of the kidney are cortical nephron. Okay, so remaining 15 to 20% are the juxtamedullary nephron. So here in the figure, as we can see, two type of nephron. One is cortical nephron, second one is the juxtamedullary nephron. Now for this cortical nephron, the renal corpuscle lie in the outer portion of the renal cortex, and they have short nephron loop that lie mainly in the cortex, and small portion of this renal nephron loop is elongated, is extended in renal medulla. For example, in this figure, you can see this one. We are discussing about the cortical nephron, and you see this is the renal corpuscle, right? Then this portion is the PCT, this part is the DCT. Okay, so renal corpuscle, PCT, DCT, all this region, they are present in the cortex. Now the nephron loop, only the small part is extended in the medulla, and most of the part, as you can see, most of the part of renal tubule is present in the cortex region for the cortical nephron. Now the short nephron loops receive their blood supply from paratubular capillaries that arise from afferent arteriole. So here we are remembering that the nephron loop of cortical nephron, they receive blood from paratubular capillaries, and these capillaries, they arise from afferent arteriole. For example, this part, see, this portion is the nephron loop. So this is the nephron loop, okay, and on the surface of nephron loop, as well as these PCT and DCT, how all this portion they receive the blood supply. So this nephron loop, PCT, DCT, so on their surface you find the presence of paratubular capillaries. And how this paratubular capillaries are originating, so here you see, this one is the afferent arteriole, which is coming out from renal corpuscle, and many small branches are formed, and these small branches, network of these small branches are known as paritabular capillary, and this paritabular capillary, they are present around PCT, DCT and the nephron loop for cortical nephron. Okay, so this is the 10th point, and this, for this point, this is the figure. Okay, now we are discussing the 11th point. Now, as I have told you earlier, that 15 to 20% nephron of the kidney are juxtamedullary nephron. Juxta meaning near to. So 15 to 20% nephrons are the juxtamedullary nephron. Here it is. For example, this entire nephron is the juxtamedullary nephron. Okay. Now, for this nephron, juxtamedullary nephron, their renal corpuscle, where it is present. So, their renal corpuscle lie deep in the cortex region, and it is close to the medulla. Here you can see, this is the renal corpuscle, this is the cortex. So in this entire cortex, this renal corpuscle of juxtamedullary nephron lie deep inside, and this renal corpuscle is present close to the medulla. Okay, so this is the medullary region, and this renal corpuscle is close to the medulla. Then this nephron, juxtamedullary nephron, they are having long nephron loop, and this loop extend deep into the region of medulla. So here, as you can see, this is the long U shape. This is the long U shape renal tubule. This part of the renal tubule is known as the nephron loop. Okay, so we can say the juxtamedullary nephron, they are having the longer nephron loop which is extended in the medulla. Okay, so this is the 11th point that we have discussed. Now we are discussing the 12th point. Now the long nephron loop of juxtamedullary nephron receives blood supply from peritubular capillary and from the vasa recta. So now here we need to remember that in case of cortical nephron, it was the peritubular capillary that was supplying blood to this nephron loop. But here, in case of juxtamedullary nephron, this nephron loop, okay, provided with the blood supply with the help of one is vasa recta and peritubular capillary. So both peritubular capillary and vasa recta, both this capillary network, they are supplying blood to the nephron loop of juxtamedullary nephron. Okay, so this one is the 12th point. Okay, now we are discussing the 13th point, and 13th point is the final point of our today's discussion. Now the 13 point. Now in addition, the ascending limb of the nephron loop of juxtamedullary nephron consists of two portions. See, a thin ascending limb followed by a thick ascending limb. So this I have already shown you in the figure. Okay. Then the lumen of thin ascending limb is same as the area of the renal tubule and is only the epithelium that is thinner. See what they are trying to explain us that see, let's say this is the juxtamedullary nephron, okay, and in juxtamedullary this is the see nephron loop, this one, this is the descending limb, okay, then see larger diameter, so that's why thick segment. Now then there is a decrease in diameter, so this is a thin segment, okay, then thin segment, descending one, then hairpin like turn they form, and now this renal tubule is ascending, going upward. So here again the diameter has increased, okay, so that's why this portion is known as ascending limb, and this ascending limb finally opens into DCT. Okay, this much we know, but here this portion, for example this portion, okay, the diameter of this portion is somewhat similar to the diameter of PCT and diameter of DCT, okay, but in between in some region, as you can see, there are differences in the diameter of ascending limb, descending limb, thick segment, thin segment, okay. So here we can find the variation, but here in this portion, this hairpin like region, so here this diameter matches with the diameter of PCT and DCT. So that point they are trying to explain us in the point number 13, okay. 1 minute. Okay. See, the lumen of the thin ascending limb is the same as in the other areas of the renal tubule. Only difference is only the epithelium that is the thinner one. Then nephrons with long nephron loops enable the kidney. Now we have seen the long nephron loop for juxtamedullary nephron, okay. So the nephrons with the long nephron loop, they enable kidney to excrete very dilute or very concentrated urine. So with the help of nephron which are having long nephron loop, the kidney is able to produce very dilute urine, or kidney is able to produce very concentrated urine, okay. So with this we have completed this discussion on the nephron. Now I would like to show you some of the figure, okay.